1.5, number 11, trying to figure out if it converges or diverges. Nth term test is usually a good place to start. So if you want to find the limit of this as n goes to infinity, well, we get infinity over infinity. I guess L'Hopital's probably be a good way to do it. So derivative of the top is itself times the natural log of its base. Bottom is itself, natural log of its base. So I get 3 to the n minus 1 over 3 to the n. So there's one more 3 on the bottom than there is on top. So it becomes 1/3. And the nth term test says that if you don't get 0, it's going to diverge. And we got 1/3, so it diverges. If you wanted to, so this is how I would do this problem. Example of a direct comparison test, we could compare it to this, where we sum 1/3 as n goes to infinity. Well, we know that one diverges because you're just adding 1/3 plus 1/3 plus 1/3 and so on. And then if we compare 1/3 to 3 to the n minus 1 plus 1 over 3 to the n, which one is bigger than the other? We know this one diverges. So 3 to the n minus 1 over 3 to the n is 1/3. So if I'm adding 1 to it, this is bigger than 1/3. It's almost the exact same thing, but it's just a little bit bigger than 1/3 just because of the plus 1. Okay, so if I know that I have a series of 1/3 that diverges, and I also have another expression that is bigger than 1/3, then this one must also diverge, and it would be, in this case, the direct comparison test. Just another application of the direct comparison test.